Today we are talking about 3.4 linear programming. To do today, you really must need to know how to graphically solve linear systems of equations and inequalities. Linear programming is a method of finding a maximum, a max, or a minimum, min, value of a function that satisfies a given set of conditions. We have a constraint, the given set of conditions. Those are your equations that you're going to make. Feasible region is a solution set of the constraints. That is where you are the shaded part. So example 1. Jillian is planning a green roof that will cover up to 600 square feet. She will use two types of plants, a blue lagoon sedum and a raspberry red sedum. Each blue lagoon will cover 1.2 square feet. Each raspberry red will cover 2 square feet. Each plant costs $2.50, and Jillian must spend less than $1,000. Write the constraints, the equations, and graph the feasible region. Okay. Well, if we think about it this way, there's several things we need to know. First, we cannot have any negative flowers, so we're going to have B for the blue has to be greater than or equal to 0. We can't have any red negatives either. So those are our first two. Now, we have two different things we're talking about here. We're talking about square feet, and we are talking about money. So we need to put our monies together and our square feet together. Okay, so we have 1.2. That is for which one? That is for the blue, 1.2b, plus 2, and that is for the red, 2 red. So that's how much space it takes per blue and how much space it takes per red. Okay, we cannot go over. It says we have up to 600, so that means we cannot go over, so less than or equal to the 600 square feet. Then we also have our other one as our money. They each cost $2.50, so $2.50 for the blue and $2.50 for the red. Once again, we cannot exceed $1,000, so it has to be less than or equal to. So now we need to graph this. Okay, there are a couple ways of doing it. Since we need to be positives and positives, because that's greater than 0, we really only need to graph in this region here. Okay, now, I could solve for one of these if I really wanted to. What's going to be easier, I think, is if you find the intercepts. So if we have, remember, intercepts when you plug in 0, so 1.2b plus 2 times 0 equals 600, so that goes away. We have to take 600 divided by 1.2, and we get 500. So B is 500. Okay, now we also need to do the same thing for our R, so 1.2 times 0 plus 2 times R equals 600. That goes away, divided by 2. R is 300. So we need to graph these two. So, oops, that's supposed to be 500, not 50. Okay, we also need to do the same thing for this one. So if we have 250B plus 250R, which is now 0, equals 1,000. That goes away. Divide by 250. So 1,000 divided by 250. So B is 400. Well, that's going to be the same thing here if we change just because they're the same number. So R is also going to be 400. So it looks like we need to count by 100s or 50s or something like that. So I'm going to count by 50s just to make it a little bit more accurate. So 50, 100, 200, 300, 400, 500, 100. So So remember, we're in this region because we can't have negative, so we have to stay up here. Okay, so let's call this our B, and let's call this our R. So R was 300, so I can put a dot there, because we're doing intercepts. B was 500, I can put a dot here, and connect the two. Now over here we have 400 and 400, so 400, 400, connect those two. Okay, so we need to know where do these two lines connect, and we will get an accurate number here in a minute. We also need to know where do they shade. So we know we have to be greater than the x and y axis, but we also need to be less than these two. So if we plug in 0, 0, 1.2 times 0 is 0, plus 2 times 0 is 0. 0 is less than or equal to 600, so that's true. If we do the same thing here, 0 plus 0 is less than or equal to 1,000. So we want to be less than this line and less than this line. So we need to be in this area here. But when we get to this line where they connect, it switches. So we're going to do C and come back to B. C. Yum's Bakery bakes 2 breads, A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. Write constraints for the problem and graph the feasible region. Okay, once again, we cannot have negatives, so A has to be greater than or equal to 0 and B has to be greater than or equal to 0. Okay, so we have to put flour together, then you have to do oats together. So our flour, where's flour? 3 pounds of flour and 3 pounds of flour. So they're both 3 pounds of flour. Okay, so 3A plus 3B, and where's flour? So here. Okay, so it has at most 135, so at most less than or equal to. We cannot go over that number. Now oats, 5 pounds, so 5 goes with the A, so 5A. And then we have 2 pounds goes with B, so plus 2B. Once again, we have at most 180, so less than or equal to 180. Okay, now we need to graph these. So once again, because this says they're both positive, we are in this region here. Okay. So let us figure these out. If we plug in 0, and take 135 divided by 3, A is 45. Well, we're going to get that for B as well, so it's the exact same number. Now these we actually have to do both. So divide by 5, 180 divided by 5, A is 36. Oops, sorry, this should have been 0. 5 times 0 plus 2B equals 180 divided by 2, B equals 90. Okay, so you can count by whatever you want here. Okay, we need to make sure we're going to 45, so I probably need to count by 5s. So 5, 10, 50. So there's a 45. And another 45. So that was for this one. So those two lines connect. Okay, we're at here at 36. So 36 is right about here. We need to go up to, what's at 90. There's 80, 45, 90. So it's all the way up here in my words. So this one connects. Hold on. Sorry, there they go. So that's where they connect. Once again, we need to be greater than the axes, but we need to be less than these two. So less than is below. So once again, we are in this area. We find where they meet right here and goes to the other line. Now, I'm not going to make you do the word problem, but I do want you to solve this one on your own. Graph the feasible region for the following constraints.